All right, welcome everybody. Hi, welcome to the third episode of Live Coding with Tanmay. We're joined by special guest Omer, my friend, and we are today going to be implementing part two of the Piet compiler that we started last week on Wednesday. So just to give you a little bit of context, last week we started working on a project implemented in the Go programming language, and the idea of the project is that we can take in some sort of I guess you could say low-level assembly code that we're sort of creating the instruction set for, and then take that assembly code and convert it in a way to an interpretable image that can be run by something called a Piet interpreter. So Piet is an esoteric programming language where programs are represented by images. And so before we begin, though, quickly I do want to introduce my friend Omer, who's going to be helping us out with the implementation within Go and the logic behind the Piet compiler. So Omer, would you like to quickly introduce yourself?
Hi, my name is Omer Kamal. I'm a software developer at IBM, and Tanmay is one of my colleagues.
Perfect. Thank you very much. All right, let's get started. So once again, we are going to be implementing this compiler in the Go language. It happens to be Omer's favorite programming language, which is convenient for
Let me fix
situation.
that. It's the language I've been using the most in the last 2 years. Okay,
All right.
my
That's
favorite
fair.
language before that was Java. Don't hate me on that, since
Okay,
I know it's
well,
kind of outdated. But
it's all I can say is it's good to know that it's changed to Go.
you're hoping in 1 more year will change to Swift.
Hopefully, we'll see.
Maybe if I have to work with Swift constantly, maybe it will become my next favorite language.
Who knows? Swift is a great language. But anyhow, today what we're going to be doing is continuing our implementation of the Piet compiler. Now we want to get as far as possible today, so quickly, just like we set sort of an expectation for last week's episode, we're going to set an expectation for this week's episode, see if we can achieve that goal by 12, so within the next 2 hours. Today we're going to try and expand this to work with more instructions. Last time, we got a single basic block to render correctly. Now we're going to try to get a couple more instructions to render so that we can do that. That shouldn't be too difficult. That should just be like expanding the instruction set that we've already got. And then once we've got a more complex instruction set to work with, then can we build a canvas? Can we put two basic blocks onto that canvas and just have an unconditional jump from one basic block to another? So from the beginning to one basic block, and then from one basic block to another basic block. If we can get that to execute, we're on our way to having this compiler being finished. And who knows, maybe we can get even farther today. Let's see. All right, so just really quickly though, before we continue, in case you were watching last week's live stream, and in case you were following along, we have made a couple of high-level changes to the code. One of the things that you may have noticed, and this is something that Omer brought to my attention, that really
It
which
was
really
funny.
highlighted it was a pretty funny situation. So we were using maps for index to instruction and color palette, where each string or each integer here would map to another integer index, and it was just enumerating zero through however many indices there were. Uh, but I mean, if we're just mapping from zero to however many indices there are, we could just be using an array. We don't need to be using a map. And so we switched that over to arrays instead, fixed a couple of typos in the code, and we also made it so that basic blocks are their own type. And that way, instead of calling a function and passing it a list of instructions and then having it render the basic block, instead we have a type called basic block, which is just an array of instructions that you can call the pietize function on, and pietize will take that basic block and render and give you like the actual colors to put onto the image. And so, Omer, what do you think we should start off with? Do you think we should start off with implementing more instructions?
Yes, let's create an example that we have to do unconditional jump, and then
All
let's
right,
render both blocks. And then I
perfect.
don't know if you want to do this concurrent right now, or we can maybe do it later on if we need to.
We'll do the concurrency later. I feel like right now we want the main logic down. And since we're just doing like an unconditional jump, it doesn't need to be like a genuine example. We could quite literally just have two basic blocks like main and do add, and we could just do jump do add. And I feel like this is a good enough example to begin with. What do you think?
Yeah, let's do that.
Okay, because it's
Do
unconditional anyway.
Yeah. Okay, we can do that, something like that.
Okay. We will require a little bit of refactoring instead to do the conditional jumps, because then we're going to need to render like two two blocks out, but we can handle that later.
Okay.
So here's what I'm thinking. Omer, could you maybe go ahead and, you know what? Actually, we don't need to implement more instructions because we're technically working with the same example as before,
Well,
just with
the
the
only
extra
thing
jump.
the only thing we really need to implement is the jump.
Jump. Yeah,
Yeah.
exactly. And I feel like to implement jump, what we would really do is at the end of, we would just, the jump would just be a white block. Because then what would happen is the second stage of compilation, which would actually take a look at the connections between basic blocks, would then actually go ahead and run the connection between those white
Yeah.
blocks.
So
But jump will just be a white block.
let's do this. Let's go in stages, right? So the very first stage is let's render two of them together. And then from there, we will try to implement any pathfinding algorithm. Could be Dexter, could be A-star, or it could be even a
Sounds
built-in
good.
one. I doubt we will do that. And then if we can do that, maybe we can do a conditional jump based on how
Mhm.
far we can get in this 2-hour lifespan.
Sounds good. All right, so in order to actually render both of them together, I'm thinking we create like a basic block canvas type, and
Mhm.
then on that canvas, we iteratively place basic blocks on it.
Yeah, and there's two things we need to keep in mind: the start and the end. So when we do the connection, we know exactly where they are and the exact location of what block is being printed where.
So in order to do that, what we could do is take each basic block and assume each basic block has, well, so it has a height of 3 blocks. So unlike last
Okay.
time, we're no longer rendering them side by side. We're rendering them like top to bottom. So we're going to assume each one has a height of 3 blocks, and we'll give them 5 in total, just 2 extra for padding, one on the top, one on the bottom. So each basic block will have 5 pixel height total. And in order to calculate the width of the image, we'll just take the longest basic block and add
Yeah.
like 2 to the end, just so that we have space for wiring.
Yeah. I don't think we really need to worry about like the pattern or even keep track of that, because again, every time we add a basic block, we know exactly where everything is, and we
Yeah.
just assume we can just put it anywhere we want.
All right.
So I'm guessing we gotta create a type that have all the instruction sets, at least the label, and also the start and end location. So do you want to do this as a map? Do you want to do this as a new type? How are you
I feel
thinking
like
of this?
I feel like the first thing we should do, even before we get into that, is just create like a simple function that can take an array of basic blocks and just render them all out to a single image.
Okay, let's do that right now.
All right. So how would you say we go about that?
So let's go to the very bottom.
Yep.
Yeah. So let's do this. Let's create a simple type for now, and this type will just be a 2D array
Sure. Of what?
of int
Okay, and what's the type going to be called? Canvas?
canvas, I guess, because we're gonna build off this, right? So
Yeah.
okay,
Okay.
let's go to the very bottom. Let's create a function for that canvas, and let's do add as an example.
Okay. So add to the canvas, and
Yeah,
we're going to take a basic block, I assume.
yeah, and we're gonna do a very naive implementation. So
Sure.
if the length is 0, we're just gonna add 2, and then do we want to do the pattern for this example, or should we do that afterwards?
Sorry, what type? What kind of pattern?
No, do you want to do a pad for it, like the 2 blocks on top and
Oh
bottom?
yeah, definitely. We do want to do a pad.
Okay, let me get in there. Okay, so we want to point it to it.
Yeah.
I guess we want to check if the length is 0 because we need to
So
treat
the
it
question
differently.
that I have for you here about this is about Go behavior.
Hmm.
Let's just say I have a canvas and I do
Hmm.
canvas.add. Will the add function automatically get a pointer, or do I need to get a pointer to canvas and then call add?
So when you do anything to like create a function, what happens is unlike Swift, you have to explicitly say, do you want a copy of this type, or do you want to get a pointer to it? So that's what the star is there for. So you can
Okay,
get the pointer directly to it. I learned
perfect.
this the
Okay,
hard way when I did coding in Go.
yeah,
I was scratching my head why my type was never going to be updated. Then I
yeah,
realized,
yeah,
oh, there's no pointer.
yeah. Well, that's why in Swift we have in-out parameters is what they're called, but and mutating functions. But anyway,
Lucky
Go
you.
handles this a bit differently.
The thing is, I wonder if we can just create a type. Just can't. Let's do this. I'm just gonna change the type
Okay. Well,
slightly.
actually, I'm wondering if the actual canvas should not just be a simple type, but instead should be an actual structure where we hold
Yes.
things like, where the last basic block is located and where all of their starts and ends are.
Yeah, let's do that because I feel like that will probably be less headaches in the long
Yeah,
run.
exactly. Because then we only need a single source of truth for the canvas.
Yeah.
So then we could say pixels is just that 2D array of integers. And then the starts would be a map of string to int, right? Is that how you create a map, or is that supposed to be square brackets?
Square brackets. It's
I'm
okay.
not used to Go. And ends. Or could we just store them both in one? Can we have like a tuple like this?
You can have, you can,
Nice. Okay.
no. You have to do an array.
Oh, we have to do an array.
Yeah. You can define as two if you want. I believe that will work.
Uh,
Let's just give it a try. I'm very curious.
oh,
Yeah.
could you specify the amount of elements in the? Oh, nice.
Yeah.
Okay,
Yeah.
that's good. Okay, well that's good for optimization. Although we're not really caring about performance right now,
At the moment.
regardless. Yeah. Okay, so we have the starts and ends. Anything else you think is important? Oh yeah, that has to be capitalized. Anything else you think is important to put in the canvas right now?
Um, no, I think this should be fine at the moment. And the start and end, maybe we care about the height as well, because we only know what the beginning and the end is, but that doesn't really hold a 2D like number. Are we gonna are we gonna use bitwise to get the x and the y? Or
Well, I mean, maybe we want to store the total um, height and width, right?
sure, let's do that for now.
And then what we could do is have like a function just as a helper, create canvas, right? And it would just take um, width, height, and
So
return a canvas.
yeah, so the thing that I'm gonna be worried about is that we might need to define just a square because are we gonna let the canvas dynamically just go by itself? Because if we do
No,
that, then
so
we have to go back and fill it.
we're actually gonna start the canvas with the dimensions that we know it needs to have. We're not gonna let it dynamically grow.
Okay, so let's do this. Since we already we're gonna create a function. Oh man, let me go back to my VS Code.
In that case, actually, for create canvas, let's not take width and height. Let's take basic blocks, um,
And find
and
the
that way we can actually calculate what the width and height would need to be.
okay. So let's
Um,
find the greatest of width first, and then the height is just very straightforward.
exactly.
Number of basic blocks times five. I mean
Yeah, exactly.
times
5.
times five.
All right. So, well, highest or longest block length. I'm gonna do this the naive way, and
Okay.
let's see. Longest block index? No, we don't need that. And then just if,
We don't need index.
and then just for BB index. Oh, we don't need the index either. Basic block in range basic blocks. This is so different from other ranges than these. Longest
Not that
basic
bad.
block length. If longest basic block length is less than the length of this basic block, then just go ahead and store the length of this basic block. Okay.
You mean greater, right?
Well, no, if the longest one is less than the current one, then store the current one in the longest one.
Oh, okay. Sorry, I'm
We're
too used to
flipping
the
them.
other way.
I technically should have flipped it around, but it doesn't matter. Logically, it's the same.
Yeah. Okay.
Okay, so then height. Why is it giving you an error for height? Because you're not using it? Okay.
Yeah, unused. So we just gotta create the canvas.
Yeah. Okay. So we have the height, and now we just need to create it. Well,
Yeah.
For the longest block length, we do want to give it a bit of padding, so longest plus equals, like, let's just say 6, just so we have 3 on each side.
Yeah, let's just get some pattern for now, and then we
Yeah.
can work with that afterwards. The next thing is we need to make the 2D
Actual
pixel.
canvas structure? Oh, yes, we need to create the 2D
Yeah.
array. Is there no automated way to do that?
Look, you still have to do a for loop, okay?
All right, whatever.
It's not my favorite, but
Okay, so let's just say pixels is.
Okay. You want to type it?
Sure, I'll do it. Gotta learn Go anyway.
So the height, and then a for loop, and you should only have to do the same thing.
All right, sure.
It's a very naive way of doing it, but whatever. We get something done.
See, I just wrote a little bit of C code, so I'm used to saying int I equals 0, but we don't want to do that.
We don't really need to do it like this, but okay.
Oh wait, technically it should be height, because then we're making this and then longest block length, right?
You don't need the array, because that's gonna... Oh, what?
No, that
Okay.
has to be an array because it's a 2-dimensional array. Right?
Why is this an error?
Expected a parentheses. Oh, Go doesn't take parentheses there. That's interesting.
Yeah, so I'm guessing it's because pixel was not defined correctly. There we go. And the longest length is... Wait, what?
Oh, wait, we were pieced. Yeah, good. Okay. So, do you think this should be the right way to create how do you create blank map? Just this? Or would it be actually like
it's a
map string
to
like that int?
Yeah.
Right.
That will also work.
Okay. This is the more Swifty way. Okay, so do you think this is good for the logic of creating a blank canvas?
Let's give that as try then. Let's create a canvas of 10 by 10. Oh, actually,
sounds good.
We cannot
or
do
let's
that.
actually pass it the 2 basic blocks and see if it's able to correctly calculate.
Before we do that, let add the conditional into the list of instruction set that we can do.
Oh yes, we would need that, wouldn't we?
Or else it's gonna fail.
Yeah.
And then just check if we can actually run this, and then we'll go from there.
Yep.
Dude.
And where exactly is white? Because we need to insert a white block.
White should be...
Well, then we would just like hard code in white, or the index for white. So what's the index for white? See, this is why we should have kept the map. We could just do length -2. Okay, let's just do length
-2. Do we want to?
I mean...
Yeah, I think we messed up by changing to index because it might be a little bit straightforward. But I'm pretty sure it's 18 fine. Or 19.
Okay, so here's what we're going to do. We're just going to set these to -2. And then what we're going to do is say if index x equal to -2 and index y is -2, then basic block equals append basic block to what's it called? Length of color palette -2.
Wait, so index is
and then we want to break.
Okay.
Okay, so what we're saying is if we hit a jump instruction, then we want to set index y and index x to -2 just because all of these instructions have to output an index on the matrix. Okay. But technically this isn't a valid index, so we're going to detect that invalid index first. And if we end up finding that invalid index, we'll append a hard-coded value to the basic block and just break the array because jump has to be the last instruction in the basic block. And we ignore anything else after that if there is anything. But if it's a valid index, meaning it was one of the other instructions, then we'll handle it normally. Is that fine? Omer, does that make sense? Oh, you're muted.
Oh, I didn't know I was muted. Was I muted the whole time?
I think so.
Oh, damn. I was talking half the time.
Oh, well,
Whatever.
anyhow. Okay, so yeah, we have the basic block logic done. That's good. Now we just need to add the instruction validator, which will basically just check if we have a single argument. So for jump, we're going to have argument count validator 1. Also, another thing that I did, everybody, while we were gone, like not on the live stream, I changed it so that the argument count validator. So I built a default validator called the argument count validator, which is a function that takes a count and creates another function that checks if the arguments have a certain length. We also changed it so that the validators don't just return a Boolean, they also return another set of arguments. So if we need to process the arguments somehow and change them, then we can do that directly within the validator. So for example, if we're pushing a string, then we want to be able to like merge the different tokens into a single string argument. And we can do that through the validators themselves now. And of course, there's also the default validator. So
Yep.
that's something that we also changed.
Okay, so let's go to the very bottom. Let's just render everything, all the basic block.
Sorry?
Let's just start rendering all the basic blocks that we have.
Yeah. Okay.
At the bottom.
So then we would need the add function again. Oh, or well, maybe we should first try seeing if we can render these.
Yeah, we don't need it at the moment.
Yeah.
Let's do. We don't care with index.
Maybe we don't want to do a loop right now. Maybe we'll just hard code main and do add. Right.
Do you want to? Because all we really need is we need to get all the basic block into the 2D array, like the 1D array, and then we pass that over to our function.
Okay, sure. Yeah, go ahead, do that. Is there no way that you can get like all the values from a map in Go?
You usually
there should be. Come on, there has to be a way. Get values from map Go.
Get keys, you mean?
No, the values.
You just do a for loop.
Oh my god, yeah, you actually just do a for loop.
Yeah.
All right.
You get the key and the value.
This language is simultaneously high level and low level.
It's okay.
All right.
So we don't really care. Actually, we might need the key, but we will see. And then we want. What are we returning? A basic block?
Just create 2 things: BB names, which will be essentially just a list of strings, and also BBs, which would be the actual basic blocks.
We messed up.
Why?
Go back to create blank canvas.
Let's see.
We shouldn't be passing it. Go to the very top. We shouldn't be passing it basic blocks. We should be passing it a 2D. A 1D integer array.
Why?
Because once we get all the, if we go back to the bottom.
Oh yeah.
Because when we palletize it,
yeah,
it's not a basic block anymore.
Rendered basic blocks. Yeah, good catch. Good catch. That shouldn't really change much though, but still.
Just change the names.
Yeah.
No. Yeah, we're gonna get that.
Okay, that should work now. Also, just because it looks weird to have that there, I'm gonna move this a bit down. To like.
You can do the very bottom for now.
Yeah.
We can organize this afterwards.
Yeah, exactly. Okay, so we have the correct create blank canvas logic now, and now we can just do BB names equals append BB names and K, and then the actual basic blocks themselves. We would do like that, and then we should just be able to do create blank canvas and pass it BBs, and let's store this in canvas or C, and then let's print the canvas height and width and see if they make sense. And for now, let's comment out the rest of the code.
Yeah, I'm just really confused. Why is this not working? V should be... Oh. Sorry.
Oh, because we actually have to pietize the results.
Yeah. I was a little bit confused why it didn't work then. Got it.
Okay, so this should be good to go now. You should be able to run this.
Yeah. Let me open up my terminal.
Although we're not using... Never mind. You can run this. I see a question from Fluffy. He asks, I just joined. What image format is this using? Well, technically, we could use any image format with Piet. Right now, we're doing like a raw bitmap. So in Go, we are building a raw bitmap.
And then on top of that, we're going to convert it into a PNG afterwards.
Yeah, and then we convert it to a PNG, yeah.
Okay, for some reason, I cannot...
Someone's also asking, how can we work on the same project together, which is also something that took us some time to figure out, but we're using a live sharing feature in VS Code to do that, but we do use Git for version control. So that's something to keep in mind also. But yeah, so I don't think I have access to... Oh, I do have access to your terminal. Okay.
Yeah, I give you access.
Perfect. Okay, so where are we? Okay, we're in the right place. So we should just be able to run. Nice. Okay, so our height is 10, which makes sense, and our width was 18, and I believe that does make sense.
Does it? Oh yeah, because we add in a bunch of like 5s and stuff like that. We haven't really done any complex optimization to reduce that.
Yeah, exactly. And plus, we do want to have enough space for the wiring because we want enough space for pathfinding to be able to actually do what it needs to do. Right?
So the height was 10, which is correct. Okay, and then did we pad it? You know what? Let's do this. Let's convert it into actual pixels, and then let's render it.
Can we do that?
Yeah.
With the code that you already have? Sure.
Yeah, we create the functions.
Remember, though, that we don't actually put the basic blocks on the canvas right now. So you're just going to see a bunch of black.
Oh, yeah. I forgot. It's okay. Who cares?
Well, yeah.
I just want to check if it's possible to even do.
Or if the size looks right.
The width is going to be c dot width. Actually, this is the height, I believe. Go one. Let me see if the image is rendered correctly, and then we can go from there. Did not save. I need to see why. Render image. Oh, width and then the height.
Oh yeah, you can't just hard code that anymore.
And the scale. Okay, let's see if this fits in. Okay,
so I got a bigger PNG images in VS Code, but whatever.
Yeah, it doesn't share it, but again, it's just a blank canvas of just I'm guessing light red, so that should be fine. Let's actually get the render to work, and then once we do that, we can show the images. Oh, if you want, I can share my screen.
I think I actually figured it out.
Well, how to view it?
Yeah, if I just oh, never mind, I can't. Whatever, it's fine. We'll view it later. As long as it looks good on your end, we're good.
Yeah.
Okay. So, let's see here. Now we got to actually add the basic blocks to the canvas.
Yeah, so let's
go ahead and add them one by one. So, what were you trying to do with this length over here?
Don't worry about that.
Okay.
Well, the thing is, we need to offset it from the beginning, right? So the very first block that we put in, we need to offset by 2. So we have some space on top. And then we might want to offset it by a few padding, so the beginning is also empty.
Okay.
But who cares about that? Let's just add 2 of them back to back and see if that render correctly at least.
Okay. One thing that I just realized we would need to do is up here in the canvas type, we are storing only 2 integers for the starts and ends, whereas it should be 2 to end. So x and y, and then start and end. So actually start and then x, y.
Oh, what we can do is just create a function to big shift it, and then just use that if you want to go a little bit overkill.
Let's not do that.
Yeah, let's do naive. The first, let's just make it full.
Yeah.
No.
Okay.
Oh, you want to do this?
Yeah. I feel like this would be the
Uh,
easiest way to do it.
okay. We
All
don't
right.
really care about the start and at the moment. We need to make sure that we create the canvas correctly. Let me fix that right now on the bottom. Okay.
Well, we do need to know where we're putting this in terms of y. So last y would be equal to canvas. And how do I get to like an object from the canvas is a
You don't
pointer, and in C you would do this.
you don't need to dereference.
Oh, you don't? Oh, nice. Okay.
Yeah, you don't need
Uh,
to worry about dereferencing.
in that case, that's
Just
nice.
treat this very similar to Swift,
Okay.
where you don't have to do the dereference.
All right. I mean, in Swift, you would need to if you had a pointer, but
You do? Oh, with this. Oh yeah. Look,
well,
I'm
no.
not expert at
If you were
Swift.
using an in-out parameter, then which is kind of like a pointer, then you wouldn't need to. Whatever, it's fine. But I'm assuming this is more like an in-out than an actual pointer.
Yeah, and also, are you getting the length of a map?
It's not a map. Oh, it is a map.
It's a map. I'm just so
Maybe. Hmm.
maybe we don't want a map, but again, a map will make it more
Okay. No,
simpler.
we still need a map, but then in that case, what we're gonna need to do is actually store like last basic block
Yeah,
and change that every time. Oops.
sorry.
And in that case, let's also change the create canvas function to deal with that so that we have nothing. Um, so Go doesn't have ternary operators, does it?
You mean like overriding the operator? No.
No, like I mean like single line of statements.
Oh no. I wish it does, but it
Yeah.
doesn't.
Okay, so then if the last basic block is just nothing, then well, so let's do last y. Can I declare but not initialize a variable?
Yeah, you put var at the beginning and then the type.
Okay. Var int last y or
No.
var last y int.
Int after.
Okay. Okay, so then I can do here last y would be equal to just 0
Okay, wait. Why does that feel?
versus
Oh, but not use.
else. And I wouldn't need to put the colon equals then.
Yeah, because you're overriding at that moment, which is
Okay.
useless.
In that case, I can do c dot last basic block. Okay. Good. So then we're setting the value, which is nice.
Yeah.
Once we set the value, then we have to use it. So in order to do that, we're going to add like how much padding were we doing for
Two.
the height? 2?
Two.
Okay, let's just do 2 for now. And then
Because
after
eventually it'll be
that,
5 in total.
we move x forward by 3. So then,
Oh,
x
we might need to add 3 actually.
might need to add 3
Yeah.
like that.
Yeah. I think
Okay.
3 will work. We'll check.
All right.
Because if we add
Yes, you're
2,
right, because we need to add the branches. Okay, that makes sense.
yeah.
Okay, so then for, I don't think we need the index, but we do need the color in range BB. We want to do,
The thing is, we're not getting the color, we're getting the instruction.
no, we're getting the color.
No, we're getting the instruction.
This is an array of colors.
This is an array of instructions.
Is it?
Yes.
How does that make sense?
So
When you call pietize returns colors, you know that.
No, when you call PLS, it returns something between 0 and 20. That will get translated to colors afterwards.
Does it? Okay.
Yes. So if you go back to the
it
bottom,
returns the index of the color.
and then eventually that will get translated later.
Okay, do
So if
you
you go to
handle
the
that translation in your render function?
Yeah, if you go to the bottom,
Okay. Where?
do you see where I state
Render image?
no,
Instruction to
to
pixel.
pixel?
Okay,
Yeah.
good. Okay. So I'm returning neither the instructions nor the colors. I'm returning the indices of the colors in the palette.
Sure.
Okay. So then, assuming, well, that doesn't really change anything because then I can just do c.pixels last y x equals color index, and I'll just change color to color index, and then x plus equals 1, essentially.
X plus equal. Okay. Let's
And
test this
then
out.
c dot last basic block equals, well, we would need the basic block name, so let's do that, equals basic block name, and since we have a pointer, then that handles it for us. So then all we would need to do is say c.add main, and then we would pass it BB's. What I want to do is create a new map over here from string to array of integer, and then I want to loop through A so that we can do bk equals v dot pietize, and then after that we can do just v by changing this to b, and then after, and then we can actually do b main so we don't need to recalculate that, and then do add and do add.
Okay.
And then we should, and then if we render it, we should actually get the right pixels. Do you think that?
Okay.
Do you think that'll work?
Let's give it a try. Are you gonna run it or should I?
I'll run it.
Okay, and I will check on my end.
Looks like it didn't crash. That's a good thing.
You want me to show you my screen?
Sure.
It didn't crash, but it didn't do the bad job either.
Okay, everybody, I'll show Omer's screen with you once he starts sharing.
Okay, let me share my VS Code only. Okay, do you see it?
Yep, everybody can see it. Okay, that's definitely not what we wanted. I feel like the reason for that. Oh yeah, I figured out the reason for it. Actually, you can just keep sharing your screen when I modify. You'll be able to see it anyway.
Yeah.
So if we go up to the add function, are you controlling my scrolling? Okay. So if we go up to the add, why does this keep scrolling down? Okay, go to the add function. No, just stay at the add function. No, stay at the add function. Scroll down a bit. Okay. It keeps jumping around. Okay, no,
Did we
for
set the
y,
last y?
No, yeah, that's the thing. We have to set the starts ends thing. So then we would need to do c.starts ends for this last basic block would need to be equal to a new array 2 exactly, two integer here. And for now, let's just, well, actually, let's go ahead and calculate them. So the start would be
3.
Well, no, 1 sec. So the thing that I'm wondering right now, so the first index, the first dimension will separate start and end. So this, and then it would be x, y. So the x would be 2 for start, and then would be last y, yeah, for
yeah. And then we can leave the n for later to deal with.
Or we can just quickly put x last y, which is correct. Should be correct.
X is plus, okay, should be. Okay, let's see. Let's render this and see what happens. Okay, for some reason my laptop doesn't want to type.
That's weird. What?
Can you run the code?
I've hidden my terminal and I don't know how to get it back. I don't know VS Code.
I don't know VS Code that much either.
There we go. Okay, I can run it. 274.
Oh.
Over here. Oh yeah. What?
Okay,
what was that? Wait, what is this supposed to do? It's supposed to be last Y, not.
Okay, go.
What was that? All right. If you go ahead and run now. I mean, if you go ahead and take a look at the PNG. Nice. It's
Is
a
this
little better.
is this correct?
No,
No,
but
let's do this. Let's scale it up because right now it's kind of annoying to really see. Let's scale up by like 10, so we can at least have a better image. Can you
all
please
right.
on it?
Yep.
I don't know why my terminal went to read only. It's supposed to be.
Oh dear.
Yeah, let's zoom out. Okay.
Okay. So it looks like the y-axis works, but the x doesn't. That's perplexing.
Yes, that's weird.
Oh
Let's look.
wait, no. I figured out what's wrong. One sec.
What now?
No. I figured it out. I figured it out.
Some draw.
It's a one-line code fix. One sec. Where are you going? Okay. When you scroll, for some reason it messes up my scrolling. So let's just scroll one at a time here.
Oh, are you following me?
I don't know. Can you do that?
Yeah, I think you might be following me. That's why.
Oh, how do we disable following?
If you go into the show settings, you should be able to disable
And
that.
where are the sharing settings?
Do you see this little live
Oh yeah,
stream?
that.
Yeah.
Okay.
I don't want to deal with a lot of people trying to get in, so I'm not sharing mine.
All right. And how do I disable following?
Should be an option for that there.
Oh wait, no, I wasn't following you actually.
Oh,
Anyway,
that's
whatever.
weird then.
It's fine. It seems to be working now, but whatever. Okay, so in the create blank canvas, what we need to do is say for j is 0, j less than width j plus plus. I put either by mistake, that would be bad, and also we don't have lift, we have longest block length. We would do pixels I j equals length of color palette minus 1. There, it should work now.
So just block.
Yeah, now take a look.
Do you want it?
Yep. What?
Are you sure you run it?
I'm pretty sure I had it, yeah.
Try again.
Try it again. That's weird. What?
That should not happen at all.
It should have a black background.
Okay, let me stop sharing and fix why it doesn't work on my screen. Yeah, so my VS Code just froze. I have no terminal. Sad.
That is weird.
Okay, let me stop the read only. First terminal. Read write only. Okay, I'm able to use my terminal finally.
This is incredibly weird. It shouldn't do that. It should be putting in the right values.
One sec. So the image got updated, and I see nothing. Nice.
What do you mean you see nothing?
I see the exact same image, which is
Oh,
no
really?
change. Yes.
That's so weird. This should put in black, shouldn't it?
Let's just put exactly 19.
All right, sure. See the image now?
Oh, there, it's black.
How does that make any sense?
Oh, I think I might know what's going on.
Oh, I didn't save the file before I ran it.
No, you did.
Run it now?
Okay.
Is it still black in the background?
Yeah, it's all black.
Nice. Okay, so that was really confusing. Okay, now I
let me
want to
share my
see
screen.
that.
Yeah, let me share my screen and then you can see it. VS Code. There we go. So it looks
Nice.
good.
So it renders properly.
So okay, yeah, that makes sense.
Now we just need to make the connections.
So
and in order for that to work.
Do you want to put this on the website and see how we would do it, and then see if it actually worked? Like the
Okay, so let me tell you what we need to do first, though. What we need to do is inside of add to the canvas, we need to append. Okay, so I'm going to do something really bad.
Okay.
Well, not bad. Well, not bad, but it's just definitely not optimal. I'm going to, and you're probably not going to like this, but we're going to do that.
What are we appending? Okay, let's see what happened to this.
All right, let's see if this works. And if it does, I'll be happy because I will have learned a little bit ago.
So what is this supposed to do?
It just adds a white pixel in the beginning of every basic block.
Oh, okay.
Okay.
Whatever.
So now.
I'm not being upset. But there's
All
one
right.
thing we do need to do, by the way.
Yeah.
So from the example before, we need to start from the 0, 0 and then
Yes,
connect it here
exactly.
first.
So that's
Let's
part
do
of our
that first.
pathfinding. That's part of our pathfinding.
We can do it naive. Just go down and connect to it. We know exactly where it is.
But then if we
Okay.
change the padding in the future, it's going to change. Let's just do it the
Okay.
pathfinding way.
Okay.
Um,
So
but
let
yeah, it
me.
works.
Yeah. So let me stop sharing my screen and send you the image, and then let's actually go on the website and test if it works.
All right.
And my terminal start. Okay, it worked now. Okay, let me. You know the one useful thing I love about Mac? The open command from terminal.
Yes, yes, that is incredibly useful. That is just.
Honestly, I found that more useful than actually doing anything with a Finder.
Yeah.
You can do so much more stuff with it. Okay, I sent you the image.
All right, let's see. No, not files.slack.com. I want the actual image. Okay, so I
Okay.
have test4.png. I'm just going to quickly, from my terminal, um, just in case, nb test.
So someone asked
Four.
what is the language? I'm not sure if you're referring to the actual language that we write it in or what we're trying to accomplish with this compiler. But the language that we write in is Golang, and what we're trying to do is to get an image that will work with the Piet language. Is it Piet language or Piet compiler or?
Well, Piet is the language like specification, like
Okay.
Python is the language specification, then C Python is the implementation, and npiet is the implementation that we're using here.
Okay.
So.
Hey, look, they're using PNG.
Okay.
Right.
So this looks like it's valid. Now, the way we're going to get the input is we're going to have the pathfinding algorithm do this, essentially. Um, then we're going to have the pathfinding algorithm do essentially like,
Oh, maybe we need to put one more pattern in there.
yeah, we got to do one more padding.
Yes, maybe we kind of have. Okay, let's just do it. It should still be fine. Oh, can
No,
we just
this is not
copy?
going to work.
Yeah, let's just copy the block below one down.
I can't do that here, so just for now, I'm going to pathfind the other way around.
Okay.
Technically, not what I should do, but okay.
No, but when we do a pathfinder, we have to block beside it anyways.
Yeah, exactly. Like anything around a wire is going to be blocked off.
So we did the pattern correctly. We just forgot that there's no way to put a path between
Yeah.
it. Okay, let's test if this worked.
Okay, so does this take input? What was our command again? No, it's just pushing at. Okay, so if we actually go ahead and run this, I'm going to open up the debugger. So we should be able to. Looks like the program is just like. Yeah, it's entered an infinite loop. In order to fix that, we need to enforce the following. So we need to make it so that we enter the basic block this way.
That's gonna be tricky.
Yeah, but I
No,
feel
but that's fine. We can basically say the start point is actually 1x less. So,
yeah. Okay, we'll see.
yeah, we just gotta pad it more.
And then another thing that we would need to do is make it so that this comes out of the end, like that, and
Yeah, let's see
then
how this works.
this comes out here, and then we remove this. Okay, let's try this out. Okay, so yeah, we push 5. Nice. Push another 5. Okay. And looks like we are now in an infinite loop again.
Okay, let's try to fix this.
I gotta figure out how to move to the next basic block and actually get it to work.
Hey! Can we not just connect it with the color and just make sure the white?
Wait,
Okay,
no.
do
So one sec. I feel like it would work if we did this.
Okay, let me try something else afterwards.
All right. Okay, so we push 5, and it's stuck again. Okay, what were you? What were you
So
trying?
let's replace the white after the dark red with
Yeah,
the light red.
this,
Yeah, replace this with the
pink.
yeah
The problem is
light
though,
red.
is that remember Piet runs off of instruction color differences. It would actually run an instruction if we did that. It needs
It
to be
just
white.
how did we do it last time?
Well, we were doing it the other way around. We weren't doing it top to bottom. We were doing it left to right. But then rendering becomes really difficult when we do it left to right, though.
Yes. Okay, so let's click on red, the dark red, the pop. Is that no?
This
Sorry.
one.
Yeah, click on the actual instruction
That's
set.
push.
Yeah, let's do the dark red.
Like put
Click
that
on it.
here.
Just click on it. I just want to see the instruction sets so we can use. What can we do?
Well, maybe.
Because we just need to do something like something that
No,
forces it to continue.
I feel like if we do this, it might work.
Okay, let's try it.
Let's see.
Maybe it just doesn't like to go backwards.
Oh, yes, it worked.
Oh, it worked. Okay, so I
So the
guess it's just
corners
that.
just have to be white.
Okay, that's easy to fix.
Yeah. Okay. Nice. Okay.
Okay, that's good. Let's do this. Let me
So,
just render it correctly, and then let me give it to you again to see if the pattern's correctly.
all right.
We want a pattern 3 or 4.
Let's do 4. You can never have too much padding, you know?
Yeah, it's always good. When do we set the pattern? Okay. 4, so we need to add 5 to it. Run it. And we have an error.
Also, is the stream in 480p? It shouldn't be in 480p. It should be in high resolution. Specifically, it should be 1920 by 1080. That might be on your end. I'm not sure. But if anybody else is also getting 480p, do let me know and I can see what to do about the stream.
I'm getting 720 on the screen when I'm on my laptop.
Well, okay.
So I don't know. I don't see 1080. I see 720.
All right. Well, still high res.
Okay, so I have the picture. Again, we have a lot of pattern, but we can fix it afterwards. Let me send
Also,
to you.
people really like your webcam background.
It's okay. It's just a galaxy.
That's good. All right, so I'm gonna download your new test image. Where did that go? Test 4. Okay, once more, test 4.
Also, we do have a question. Do you work at Google, Tammy?
No, I do not. That's something that a lot of people. That's fake news. I do not work at Google now.
Okay, man. You making that? What did that one video mention? How much money you were making in 1 month or 1 year? That was a funny video, I have to say.
Yeah, it was a funny video. Anyhow, so all right, so if we start off over here, we should be able to move and then move down here automatically. As long as we put white in the corners, it's fine.
Yes.
And then we should
Yeah,
just
we
be able to.
might not need to pad the first one so much.
Yeah. Okay, one sec.
No,
I went
we
one
messed
far
up.
too down. Yeah.
Yeah.
All right,
And I
so
think we
if we go
pad a
over
little too
here.
much right now.
Yeah, it's fine.
Yeah, it's
When we
kind of
have like
difficult.
more complex wiring between basic blocks, we might need that padding.
Yeah, okay.
All right, so now this should work.
Let's hope. And it doesn't.
Okay, so the first one cannot follow that logic. It has to go down and to the right.
Okay. Again, the first one we
So,
can kind of hard code it to just
yeah,
start like that.
yeah. All right. Wait, I have to stop it. Starting again. All right, so push 5, and eventually this was just working literally a second ago. I think it was because I got a little overconfident and went to do that. If we do this,
Yeah,
it
also
should.
you need the white block maybe at the end. Do it.
Well, I don't think
Oh
we
no.
should.
Yes, we do, I think.
Do we?
Okay. Yeah, let's add a white block at the
Where?
turn.
Where?
Oh, actually, never mind. That should work.
Well, maybe we need to
Go from the back.
do this.
Okay, let's see. Oh, you forgot the last
What?
turn.
Oh, yeah. Okay, let's see. We're gonna really need to put some strict rules into the pathfinding for this.
Okay.
Yeah, still not working.
As long as we can understand how the path works, then that should be fine.
Yeah, the
So
direction
it can.
pointer is just stuck.
We got it to work because we add a pad in there. So was this exactly what we did last time?
Logically, it's the same, but it's not like pixel for pixel the same. At least logically, it should be the
Let's do
same. It
this. Let's do
evidently
this.
isn't.
Let's go from the bottom and see what happened. Okay.
Go
It
from the
shouldn't
bottom.
change anything, but I just want to rule this out.
What do you mean go from the bottom?
So you know how last time we going
Oh,
between the
went from the
two?
bottom and then up?
Yeah.
Okay.
I hope this doesn't change anything.
Sure.
Can you not just like hold it and just drag it across?
I cannot. I wish I could.
And then eventually, one more down. And then we will slightly change this to make it so that it can go in between. Yeah, our pathfinding algorithm is going to be really annoying.
Yeah, it's going to be difficult to implement.
Yeah.
All right. That should do it. Yeah, that worked. What? I feel like I figured it out. I feel like I figured it out.
Can we?
No,
Yeah.
no,
Can we do the
I
exact
think I
same thing
got
in
it.
between?
Yeah, that's what I was about to say.
I feel like
If
it's probably
we-
just how we enter it.
Yeah, and how we exit the first one too.
Yeah. Yeah, that's what I meant. Let's hope it works.
I do hope it works.
We all hope it works.
I don't like having to click across so many pixels, but oh god.
Whatever.
Okay. Okay, so push, and what? What are we doing differently?
Oh no, you forgot the white block for one
Oh
of the
yeah,
corners.
there. Yeah,
I hope this is the only issue.
I hope so. Nope, was not the only issue.
Okay, maybe we wanna do it from top to bottom and see if that will fix it.
Sorry?
Maybe we wanna convert it so we render it downwards, not across, like vertical versus horizontal.
Maybe if we do this. No. Huh.
Can we do this actually?
What?
So do you see the at the last corner where the white is?
Yeah.
Can you
This?
put go two to the right, and can you put a white block there?
Here?
Yeah. And can you also put a white block in the last corner?
Sure. Nope.
Okay.
Potentially. Let's try this. Let's just say we ignore this, right? Let's just say we're going to cut this off so that this never executes. Let's just say we want to push. can we end up running that push? Like, do we get there? Okay, so
Yeah,
we
we
do get
get
up.
there.
We get there. So we know it's not an issue with how we exit.
Hey, can we do this?
What?
Try this again. Like rerun it.
One sec. Now let's see if we can push a 1. Okay, we don't end up ever pushing a 1, so that's the issue right there.
Can we go to? Can we do one at the
Oh,
last
wait a
white?
sec. Wait a second. I have a feeling. I have, my
No.
my intuition says that the issue is with us hitting the edge of the screen. If I were to erase this, let's just say we were to continue down here and actually want to push, would we end up pushing 2? No, we don't get there. So it's something to do with this
Maybe we have
corner.
to consider how is the path being followed, right? Is it going to go up first, left, right? And if something's not there, how does it follow it?
Yeah. See, if we actually understood the Piet language in more detail, we'd have a much better time writing a compiler for it. But it should have followed that path. This is weird. Maybe it basically doesn't like making the forward left turn.
Can we do this actually? Can we go up one and then turn to the side? See if that'll follow it.
Up 1 and turn. Oh, wait a minute. Maybe if
A
we
pointer.
no. Let's just say we do white, push, white, and then what's the switch command? Switch, and then white. I feel like this will work now. Oh wait, no. This is the first push. The first push was going to work anyway. Then we switch. Do we end up running? What? How does that go back?
It went back. It went back. It went back. That's the
Why
confusion.
did
So
it go back?
no, it's probably just the way it is.
Come on, man. Oh wait, one more thing we could try. What if we were to put roll? Let's try this out. Yeah, no, never mind. Maybe if we even just let's just say we keep it white, like just all white. What ends up happening then? Yeah, it just goes back. Maybe if we put these in the corners. At this point, we're just trying different things out.
Okay, can we go back to where we had before?
Sure. One last thing I'm going to try really quick. Yeah, no. What were you saying?
Okay, so what we need to do is go exactly where we had before, where like we can push it on the second line.
All right, so to do that, I will just refresh this and import the PNG again.
Okay, so let's connect the beginning.
All right, and
So
then
I feel like what happened is it rather go like the direction matters a lot,
yeah,
and
yeah.
I like to go right more than left. So what if we go up first and then go left? Would that follow it? Because there's nothing to the left. But we might need to zigzag a little bit. But let's see if that worked. Because I feel like maybe we need to look at the language itself. I prefer right always, then check left like maybe the last step.
I know that there is a way to change the pointer direction.
There
Um,
is.
yeah. See this pointer command?
Mm-hmm.
Let's actually search that. Get pointer command.
Yeah, because that will probably be better if we can do that.
Yeah. Pointer. Commands. No, not Piet plus plus. We want regular Piet. We can't even figure out regular Piet. All right, so
How is it so difficult to find what the pointer does? Oh, there you go. Pointers.
rotates.
Up.
Yep, yep. Okay. So, in essence, what I'm hearing here is that let's just build our regular path like we would,
Mm-hmm.
right? So, and then I'll put the white corners in.
But we want to push, again, what direction is the pointer going to go? We don't know. Like,
So
do we
now
know exactly what the pointer is?
here's what I want to do is I want to push A1 to the stack. Whoops, sorry, no push. And then after that push, I want to run the pointer command.
Okay, let's see what happened.
And then let's see what happens. Maybe it ends up turning correctly.
Okay, let's see.
Uh, yeah. Okay, push one, pointer. No, then it ends up
Okay,
going back.
let's
We need
point.
to run
Let's
the
push two.
switch command here so that it actually turns correctly. Okay, so let's
Did it get to the
like
switch
that.
command last time? The when we run
Sorry?
it?
Sorry.
Last time we did this example, did it get to the switch command?
Get to the what? Sorry?
The switch command.
Like we did try the switch and it did work.
Okay, let's see what happens if we put the pointer here.
Okay. I feel like we might need to experiment with how many items we push onto the stack in the first place.
Yeah, that's fine. Pointer, okay. And
Okay,
then go back.
so it goes back. So let's try pushing another thing over. Okay, still goes back. Let's try
Let's
pushing
try
three. Okay, so that's not all bad because I have a feeling if we were to replace this with a push, let's just say we black this all out, I feel like we will end up executing that push now. No.
Maybe maybe it's four. They just try to like change the push like 3 to 4 and so on. See what
Well,
happens.
4 just returns to what it was before because if you turn 4 times, you end up where you were.
True.
Oh, wait. Potentially, if we put a white here and then this and just black this out, that could get us where we need to go. There we go. Okay, so we just need to move the direction pointer in the right direction.
Okay, but is the pointer actually 3? 2? to turn it like that? Or can we just
Yeah,
double check
because it
that?
was moving left, and then if you move clockwise 1, 2, 3, then it points down and it goes down.
Okay.
Yeah.
Okay.
Okay. That was infuriating, but we're a step closer. Now we somehow have to get the direction pointer logic inside the pathfinding algorithm.
Just give me okay. Okay, let's import the original again and let's build it. So we have an
Well,
example what we're going with.
what we could do, and hear me out here, what we could do is make it so that before every corner,
With board pointer. But that logic only work if we're gonna go from left to down, right? So we don't want to do the logic that it will be like a pain.
yeah, of course, we're actually going to have to keep track of where the direction pointer is going to be pointing and figure out what we need to push the stack to make it point in the right direction.
And since we have the pattern, it might be a little bit more straightforward, but we do have to be careful. Because once we get into like a complex, a little bit more complex program,
You
it
know why
might.
the thing that just really kills me is that why is there no way to just tell it to point in a specific direction rather than having to, move it that many times? Like, why can't I not
It'll
just?
be nice if there's a way to just jump to a specific location. And
Well,
it's,
yeah, I mean that would be the optimal scenario, but we
I
don't have
wish I
that
had that.
instruction set. Okay, so what we're gonna need to do then is before every corner, we're either gonna need to change the direction pointer. Oh, we're gonna need to keep track of what the direction pointer is, where the direction pointer is pointing. We basically need to build a Piet interpreter in order for this to work. Well, at least a
Yeah.
component of a Piet interpreter. Um, yeah, I don't really see any way around that. Well, let's just get started. So in this case, I wonder why we didn't need to do it here though.
I think it's because of the direction we're going from.
Or it's also because the codal chooser, the other pointer, the codal chooser is pointing to the right, so it's fine with turning right and turning right, but when it needs to turn left, it gets confused. Oh, hold on a second. What we could do is we could actually just push.
I'll be back in like 2 minutes, okay?
All right, sure. So what we could do is we could just push a single, like a 1 to the stack, and then after pushing a 1 to the stack, we could modify the codal chooser so the codal chooser tells it to turn left instead of right. The way we do that is by using, I believe, the switch command. Let's try that out. No, that brings us back. Let's see if the codal chooser does turn, though. So it's currently left. Now it's right because it needs to turn right. Now it's left again. Still left. Now the switch command turns it to the right, but we don't want it to turn to the right. So what if we end up pushing 2? It'll just bring the codal chooser back where it was, but still that might be what we want. No, it looks like we're going to need to modify the direction pointer and not the codal chooser, which does make things a little bit more difficult. In terms of the way that we would do that, yeah. You're back?
Can we do? Yeah. Sorry. Let's do this. Let's move the white block to somewhere like more in between the 6 or 7 pink block, and see if it will choose down when you go back.
Okay, sure.
Because I was feeling that it might be able to just go back to the right location.
All right.
And it's just that I hope this works.
No, it's not going to go down.
Oh, actually, can we put a white block there
Where?
instead? What the turn's supposed to be?
Where the what's supposed to be?
Do you see the drop?
Oh
Where we
wait,
do
no,
the
it's
pop?
because I didn't push 3. Okay, now try this.
Is it?
No, it's not gonna work
So
that way.
let's do this. Let's put the white actually one block up. So on that branch.
All right. No, but then this will become part of this other codal.
Let's just try it.
All right. So like this.
And no, and then put the white in between.
Oh,
Yeah. Let's just test this out.
nah.
Why is it keep going back there?
It's because when you turn the direction pointer down and it has nowhere to go, it starts turning again, and it sees it can go to the left, but now the direction pointer is pointing left, not down.
So I always prefer right over anything, and that's it. That's gonna be annoying. Can we go up and around it, and then do the same thing again?
What do you
I'm
mean?
very curious.
Or you know what? You know what we could just do? We could restrict the pathfinding algorithm to only make right turns.
Yeah, then eventually we're gonna block ourselves, like, because we need to use the.
Look. If we have enough padding, we're technically not going to block ourselves.
We might, but I feel like if we just make this vertical, it will be much easier than actually trying to do horizontal. Like we can just turn it. Like it's not that difficult.
But we would still have the right turn limitation, though.
Yes, but I don't think we gotta turn right too often.
No, if anything, I think that actually makes it more difficult because if we need to move from one block at the back, back forward, we have to do a left turn. Otherwise, we're going to go out. Like, there's no way to go back then. At least here, we can go back and forward without ever making a left turn.
I guess the only thing I see right now is that we need to make sure the wire is. We have enough length in the wire so we can do the
Yeah,
turn
that
correctly.
that makes complete sense. Like, we need to have enough space for the wires to exist.
In theory, can we not just flip the block around to make it easier for us?
Like, put the start at the end and the end at the start.
Yes. Again, for this
There are just
example, it
too
will be
many.
very
There are just too many
straightforward.
possible combinations of
Yeah.
starts and ends for us to calculate that.
Yeah, I guess the naive way will be that. Okay,
Yeah.
let's just find an algorithm that at least can draw the path to it, and then from there we will add restrictions to it.
hmm Okay,
And
so
I'm
right
gonna
now,
reduce the padding in the beginning because I think that's too much padding.
sure. And also, yeah, let's just go ahead and implement simple pathfinding that avoids left turns.
Let's hope.
I feel like that shouldn't be too difficult to implement, but we're going to need to see how we pad and how we get stuff to work that way.
Mm-hmm.
Okay.
Uh, the last one would be.
Okay, I'm going to open up VS Code now. Where are you currently? Here, okay.
I'm just changing it. So the last. Okay, so I got shifted correctly.
Okay.
Uh, okay. Which pathfinder algorithm do you want to make?
I feel like the easiest is A star.
Okay.
Let's see. I'm searching up easiest pathfinding algorithm to implement. Um, it looks like Dijkstra is probably pretty easy as well.
But do we really want to implement that one? We can just use the library and then we just convert whatever we have into that
Although we
format.
do need to restrict it from making right turns. Will the built-in version be able to do that?
At the moment, it doesn't matter. Let's just see if we can at least do it. And then from there, we will try to add. I don't know. We might need
I
to
mean, it
build our
kind
own.
of really matters because If it's making a left turn, it's fundamentally incorrect.
Yeah.
Sorry, so if it's making a left turn, it's
Yeah,
fundamentally
I got it.
incorrect.
Okay, I guess we can create our own if you really want to.
Yeah, let's just do it. It's super easy. It's trivial to implement pathfinding.
Okay. Well, it also involves us from converting the map to something else because we know
Yeah,
what is walkable and what is not.
exactly.
Okay, let's do that then.
So what we're going to do is we are going to have to store what coordinates are part of a basic block and what coordinates are part of wiring, and make it so that if a black block's neighbor is part of either wiring or a basic block, it's an invalid block to be on. Okay? You are muted, by the way, just so you know. All right, so what we're going to do is inside of the canvas structure, we would create another set of arrays. So
Okay, I'm unmuted now. I was just doing something
invalid,
else.
yeah, invalid blocks, invalid coordinates. So that would be an array of 2 integers. Coordinates.
Yeah.
And then when we add a basic block to the canvas,
We
what we
block
want to
those
do
out.
is, yeah, so for when we do this for I thing, or no, over here when we do this for thing, we want to add c dot invalid coordinates equals append c dot invalid coordinates, an array of x and not y.
You need to actually state
Specify
it.
it's an integer.
Yeah,
God.
yeah.
Okay. So
Well, oh yeah.
all right. That just stores it, and now we gotta do the wiring.
Let's do it. Function. Get a canvas and we gotta do wire
Wiring.
from one block to another block.
No, we're just gonna get
Oh,
XY.
okay.
Well, start and why is this an error? What? Invalid
Other way
type.
around. Type is after.
Wait, like this?
Yeah. Isn't the same thing in Swift like that?
Yeah, it is, but I got confused for some reason.
I think most languages are like this.
Yeah, they are.
Well, most are like new languages.
Yeah. Anyway. Okay, so we're adding wiring. In order to add the wiring, we gotta implement pathfinding. So let's do that, shall we? I've got Dijkstra's algorithm pseudocode opened up in front of me. Let's implement that.
Okay, so for each node in the graph, set the distance to infinity, set the node per. Okay. In theory, what we can do is the distance for every left turn will get penalized like crazy, so it will try to avoid as much as possible.
Or even just say that it's an invalid neighbor to move to.
I guess.
I feel like
So we
that's
just
actually
block it.
easier. Yeah.
But eventually I have to take a hit eventually once. So
No, we're just saying that's not an like if you're, let's just say you're moving down, right? Or
yeah.
let's just say you're moving left. Moving
Oh, so
down won't be an option.
from left to down. Oh, okay, that makes sense.
Like
So we can
if
only.
we're moving left currently, then oh wait, but how would we know the movement direction though?
So we get the last location and
Oh
Dexter.
my god, this is just gonna be.
A built-in one could in theory do it because if I'm correct, actually no, I don't know if you can get the last distance in
Let's see, actually,
built-in ones.
prevent turning in a direction pathfinding.
For you to. Oh, making turning costs. But again, we don't know what the current direction is either.
Yeah, I mean, penalize left turn. Dijkstra. Like, how do we keep track of that?
Let's see, maybe this will work.
No, Dijkstra cannot incorporate turn penalty directly.
So we build our own.
Okay, so it's possible to rewrite your graph so that every turn is associated with taking an edge. I don't get what that means. Because, like, moving down is fine from a block as long as the last block you came from is... Oh, wait, no, what we could do... No, actually, I figured it out.
Okay.
All we need to do is so the way that Dijkstra works is it's not going to continuously build a path. We're going to build a map of valid connections, and then what we end up we find our way back through that map of edges. And what we can do is we can just make it so that when we're doing that back tracing, we don't count invalid moves. But then the problem is that map. So you see the pseudocode on screen right now?
Yeah.
The idea is that you have a map that takes a node and stores its parent node. And we could make it so that the parent, based off of the parent, we determine the direction that we're moving.
Can we not pass the direction as we consistently built the whole point, like the node?
But the thing is, Dijkstra's algorithm doesn't work like that. It works like this. Like there's this little animation here. It's like it's not replaying for see. It's like it's not going to consistently move in one direction. It's looking at the whole edge of the graph at once.
But first.
Oh yeah, almost.
Yeah. But we do kind of want to limit where, like, how the search happened, so we can at least get something faster.
Well, I mean, remember, we don't really care about performance right now.
Yeah.
That's an afterthought. But what we do care about.
Okay, let's do this. Let's just implement this, and then from there we will try to change it so it will go to our exact use case.
Okay,
because
let's do that.
We got 30 minutes left, so let's see if we can at least implement Dijkstra.
Yeah,
and then we go from there.
That shouldn't be too difficult. Just raw Dijkstra. All right, let's do this. So for each node in the graph, set the node's distance to infinity, set the node's parent to none. So we want our distances. Well, would you use float or double?
Wait, what are you? You want to do a map of
a map of coordinate to? Oh yeah, I forgot that.
No, but I don't think this is a valid. I don't think you can do this. I guess you can.
You can't use an array as a key. Arrays are hashable if the elements are hashable, right?
It doesn't narrow out on you, so let's hope it works.
I think it'll work, man. All right, you can do it in Swift at least. I don't know how it'll
go. We like it. It doesn't complain so far on your screen.
Do you use floats in Go?
Yeah, floats are fine. You want float 64 or 32 or just regular float?
32 is fine. Like, do you have to specify? Oh.
Yeah.
Okay.
I'm actually shocked that this works.
Why? It should work.
I never tried it, okay? So this is also something new for me.
All right. unexplored set would be this. And this will be equal to all the indices. So for height in would be equal to 0, height less than canvas dot height, and height plus. Let's actually do x first. And then let's do something similar for y.
Okay.
So that way we can do unexplored set equals append unexplored set x, y. So now we've got the initial stuff done, and then while the unexplored set isn't empty, so while or for how do you do while a certain condition is true?
So for a condition in there.
That's it. That's all you do.
So imagine a for is literally everything.
Every
Okay, it's
kind of loop. Every kind of loop is a for loop.
Yes, in Golang. So
All
anything
right,
you can do.
I'll take it. I'll take it. Okay, so
okay,
while
if we really want a while, just change the compiler to go, and we can call it Go plus plus.
just a single syntactic difference. Okay,
No, we will add generic. Okay, if you're gonna go that extreme, I might as well add something I do need.
Yeah. Okay, so what we would also need to do is say distances set. Yeah. How do you get infinity in Go?
Math dot infinity, I guess.
Like that.
Let me look it up.
How do you get null or nil or whatever you use?
I think it's in math.
Oh, really? Null is in math? Never mind. Let's not do that then.
Because the thing is, when you come into like numbers being like is like nothing, unless it's a pointer, it cannot actually be null.
Interesting.
Are you looking for Golang? Come on, man.
All right.
Yeah, I think it's only possible for like a math concept.
Float 32 Golang infinity. Seriously, Golang doesn't even have infinity in its floats?
Look, no one really used it. Okay. Wait, what?
Sir?
Plus n infinity? That doesn't make sense. Why cannot I get?
Okay, no, let's just set it to a really high value, like 100 million. I don't know.
Sure.
This is a terrible solution, but
Sure.
whatever. So then we find the node with the smallest distance. Well, then we can do.
Well, technically, Go does have an infinite sign for some reason.
Well, we can't access it, so it's not really useful. Is that actually how you do it? Like, will this compile?
It doesn't complain.
All right, if it doesn't complain, then I guess it worked.
And then NaN is like no. So why
Yeah.
not? Okay, let me also do plus infinity above. I learned something new about math and Golang.
Yeah. Okay, so we've implemented get the smallest distance node, and then we have to remove the current node from the unexplored set. So how do you remove an element in Golang? You have to get like the specific index.
In index?
Yeah, you have to get the index.
You want to remove it?
Yeah.
How do you do it in Swift or Python?
Remove at. Or you remove and then you pass the value that you want to remove.
Yeah, about that.
Yeah,
I'm pretty
I'm sure.
sure you do slices. Let me double check.
Value equals.
Two ways to delete an element from a slice. So yeah, no, you just do slices.
Seriously, to slice around it? In what kind of
Yes.
language is that normal?
You slice around it, okay? Hey, don't blame the language,
Okay,
okay?
okay, fine. You know what? If that's what Golang wants, that's what Golang will get.
Hey, this is the same thing with a lot of languages, okay?
It's definitely not.
Oh my god. Okay, so the thing is, no, you just gotta slice it, man.
All right, I've sliced it. If you see anything wrong with that logic, tell me because wow.
Here. I'll give you a function, okay?
Nah, it's fine. We can just do, or sure, if you can do that.
How does this work? I'm so confused. Okay, whatever. It's fine.
Okay. So if that's where we want to be, you're good to go. So,
Oh, so do we care about how the order is or no when we slice?
one sec.
Because based on the order, if we don't care, we could do it faster way.
Sorry, I didn't get what you were saying. What did you say?
Do we care about the order that it's supposed to be? Because there's a
No, we
faster way of
don't
doing
really.
it.
We don't.
Okay, I'm just trying to understand what this one person is trying to do. So equal I have no idea what this is trying to do. But apparently this is the fastest way. I have no idea how this works, but if you do, please let me know. Because
How does what work?
it's just a bunch of slices.
Let me see.
I sent it to you on Slack.
Yeah, I've taken a look. What? All right, I'm gonna show everybody this code. Let's see what this looks like. So, si, so removing at that index is equal to.
We've taken the last element out.
Wait, no. So you're taking that element and you're somehow setting it to the last element,
Oh, I got it.
and then you're
We're just
getting up
removing the last
until.
one. So what we're doing is we're taking the last element, we place it with the current index we're trying to replace, and then we slice the last one out, which is a more efficient way of doing it because we don't actually care about appending two arrays together.
Oh, okay. God,
Okay, I got it
this
now.
logic
It took
hurts.
me a few minutes to understand that.
Yeah, it also took me a bit, but yeah,
It's
let's
okay.
not use that right now.
We're not really caring about efficiency right now.
Yeah, exactly. If we did, then we would have made many different design choices. But regardless, I'm not going to implement the backtracking just yet. I'm just going to say we found the value. But then we have to somehow implement the neighbors. So let's do that. For that, I'm going to actually create a separate neighbors function. So function neighbors. And we're going to take width, height, and coordinate, which will be this. And then essentially just candidate neighbors would be equal to coord 0 minus 1 toward, yeah, 1 minus 1. And then, well, there would be, yeah, okay, plus, and then plus. And then real neighbors or verified neighbors would be a new array, and then for no index but neighbor in range candidate neighbors, verified neighbors equals append verified neighbors n, but only if n 0 is greater than 0 or greater than or equal to 0, and n0 is less than width.
So can we go over the neighbor logic one more time?
One sec. Okay, that should be the way to find neighbors.
Okay, I do have a question.
What?
So the very first corner is the neighbor. So we check in from the x and y minus 1. Will now kind of be diagonal. Do we allow that to happen? So let me explain it here.
Oh yeah, this is only getting diagonals.
Yeah, so like we
So
need to watch out for that.
Yeah, we do not want diagonals at all.
Yeah. That's I'm like, wait, I don't know if that's correct. So we can add a plus here.
Yeah. And then we don't want to modify these at all.
Yeah. I'm just like, wait.
Good. I was actually kind of thinking about that, and I accidentally did all diagonals instead of all edges.
Yeah, I was confused.
Good.
I'm like, wait. Piet doesn't look like that. Whatever, at least we catch it now, not later.
All right. So yeah, you're right. So we have the neighbors. So let's see. Well, I guess what we could do is even get like the actual canvas. I mean, we might as well get a pointer. So that first of all, we don't need to get the width and height, but also because that way, what's that? We can also verify if it's not in the block list. So, is there no goto in Go, like C? I don't think there is, because if Go values safety, then there's no Go.
No.
Okay.
But are we talking about like go to like in a label that's anywhere, or to like
a label that's within the same function?
You can do a go to for like for loops, like most other languages.
Okay, whatever. It doesn't matter right now.
Like you can continue to a different for loop. Do you want that?
Nah, it's fine.
If you're gonna do a continue, I'm gonna change this.
I feel like we should get this to work first, and then we should get the logic good. What in the world does that do?
It just skip the. It will just go to the next loop.
That is the most alien code I have seen in a long time.
Have you never used labels for for loops?
One sec. You can label for loops?
Wait, you don't notice?
No.
Wait, have you never done nested for loops that you have to escape, like continue the parent's for loop or even the parent's parents?
Well, yes, but then I would do it a different way. I would use Boolean values and breaks, not like continue first for.
It's okay.
Swift definitely does not support that.
I bet you anything Swift does have this. I believe. Okay, so C++, C, I'm pretty sure have this. Java have
Look,
this.
C and C++ don't have like labeling for loops. They just have labels in general.
Okay, yes, but like, I want to see if Swift actually have it.
I can guarantee that Swift does not have this. Yep, they don't.
Don't they?
Yeah.
Wait. They do.
What? Let me
They do.
see.
Unless you're telling me this code is incorrect, I'm gonna send you on Slack.
Oh my god, they have this.
Yeah, I sent. Yeah, this is what I was looking at. Yeah, they do have it.
I'm gonna tell you something right now. In all my years of Swift programming, I have never seen a single project, no matter how complex, ever use this feature.
What it? Look, unless you know it, you don't use it. Okay.
Yeah,
And a
but
lot of
like,
people that write Swift code
wow.
are not really. They do it for iOS anyways, and
No, but the thing is, though, they're like I can guarantee IBM Couture code, the Alamifier source code, and a bunch of other large Swift projects don't. I. This is wow.
so
One
let's
sec.
do next week
Okay.
a live stream me teaching Tammy about the language of Swift, which is your favorite language.
Wow. Okay. All I can
You,
say is I'm just very surprised. All right. I learned something today. I'm one of today's lucky 10,000. Is,
just to
is what
let you
I'll
know,
say.
you can also break.
Yeah, yeah, got it. I got the point.
Yeah. So you can do break and continue.
Wow. All right. Okay, so yeah, so we can continue first for we have the
You know the
verifiers.
funniest thing is this is actually my
What?
first time using this in Golang.
Oh, really?
So I wasn't sure if it will work 100%. So I'm like, no, this should work. It's based off
Interesting.
Java, C, and Python, so it'll work.
Nice.
Oh, and I think Python also have it too. That's where I use it a lot more.
Mm-hmm. Unexplored.
You want pointers to okay. I do
Um,
need to double check. I think by default, when you pass in an array in Golang, you get the reference. But again, if you pass a pointer and dereference, then it should be the same.
yeah. Okay, so we're nearly done the pathfinding. If unexplored equals n, which is our neighbor, then we want to break and say valid true, or what's it, false, and then valid true if valid. Okay, so we should have genuinely verified neighbors now. So we should just be able to do SD neighbors would be equal to from what coordinate? Smallest distance coordinate. The unexplored set. How do I pass a reference to the unexplored set?
One sec. Okay. You want a reference?
Yeah.
Oh, you do the ampersand sign.
Oh, just like C.
Yeah.
And Swift.
And and every other language except for Java.
How does Java do it again?
I don't think Java have pointers really.
Oh, interesting.
So like, I don't think it's possible in Java because if you want to pass something, you just point into a class and just pass that class. I don't
Yeah.
know how else there is, unless it changed in Java 8, which is the last time I really use it.
Okay, so we have the neighbors. Now the new distance equals current node distance plus the distance between the current node and the neighbor. The thing that I don't get, current node's distance. Shouldn't the initial distance be negative infinity?
Okay, for negative. It doesn't say where. Does it say infinity or negative infinity?
It says infinity, but I have a
Infinity is
feeling that's
usually.
wrong.
Oh, okay. Can we
Let's
not just
see.
copy a Golang implementation of this?
We absolutely could.
No, it just infinity. It doesn't say negative.
Yeah, you're right, actually. The thing that I don't get then is that when we add the length, that's just going to continue to be infinity.
Yeah, you're right.
How does what? Oh, the source node has a 0 distance.
But aren't you just keep adding infinity to 0?
No. It makes sense.
Okay.
Distances start equals 0. Parents start, of course, it's going to be none. Unexplored set. We would want to keep that actually. Okay. So then we have the neighbors, and then once we have the neighbors, we do need to remove, well, we did the removal. For each neighbor, so then just do for neighbor range SDU neighbors. The new distance, so new distance is equal to distances for the current node, right? Yeah, current node. So current or smallest distance coordinate plus 1. And then if the new distance is less than the current node's distance, so, that's
Yeah.
never going to evaluate to be true. Oh, distance to the goal. Okay. Yeah, so we would need to quickly implement Euclidean distance. So point A, we're almost done here. Point B, and we want to return a float. So we would just do A0 minus B0. We want to square this. Yeah, we want to square this. How do you square something in Go?
You just time it by itself.
Like, can you do this like Python?
It should be. It
All
doesn't
right.
error out.
So X, D, and Y,
The thing is,
D.
I haven't really done a lot of math like stuff here, so it might not work. Might work.
Plus YD. And how do you square root something?
Math.square. Yeah. And expecting floats. So
How do we convert these floats?
this should be converted to floats already. It doesn't
Just
complain
that?
either. Yeah, sure. I believe it needs 64. Float 64.
Oh, we can't. Okay. Then we'll cast the output to 32.
Let me double check the function is correct.
Yeah,
So
just like
is
take
the
this code out and test it out.
no. So it should work.
Okay.
Like if it doesn't error out, we just assume it work. Like that's the best way to do it.
Less than Euclidean distance from, or actually distances smallest distance chord, then we want to do that, but also over here, we do want to set this to the actual Euclidean distance from start to end. And then we can say alt. What's alt? Oh, okay. Distances for the neighbor. Distances for the neighbor equals the distance, and parents for neighbor equals.
I feel like to test it, we just start with a blank canvas and just like, how does the path create?
Yeah, from like 0, 0 to 10, 10, or the other corner.
Yeah. Let's see how that works.
What would this be? Yeah, smallest distance coordinate. Okay, so in theory, this should be like a valid pathfinding implementation. It's not actually going to give us the coordinates like in between, like it's not going to tell us how to pathfind, but it'll do the pathfinding, and it should print out we found the value. Let's see if it does that. So I'm going to quickly comment out basically all of this code. Well, we couldn't really do all of that because we need the blank canvas, but I'm going to comment out this code.
You comment too much.
Did I?
Yeah, no. You just continue. I'll fix it.
All right. C dot add.
We still want to convert it to some pixel, right?
No, we don't, because we're not going to get any pixels.
It's fine as long as we have something fill in.
Right, sure.
Aren't you filling in the?
No, we're not filling in the path.
Oh, we're not filling the path yet. Okay, let me just comment it out like you mentioned.
Okay, let's just see if this runs properly.
Unexpected.
No, 305.
Where's 305?
This. Oh yes, it accepts a comma at the end, of course, because we're programming Go.
And
oh
dear, that's a lot. Okay, click on the.
Yeah, you were right. It doesn't support maps with arrays in the keys. All right, so it looks like we've got a couple of errors, and it also looks like we've reached 12 o'clock. Yes. So here's what we're going to do. We're going to do
Before we continue, we can just do a workaround.
Which is?
We can just define a type called point, and this will just be a tuple.
Oh, yeah. All right, sure, we'll do that. But anyway, let's just quickly see if we have any questions on the chat about this code. Let's see. Looks like
the only question I see is, do you work at IBM Watson?
Well, not at Watson, but I do work with IBM on a couple of projects. So yes, but yeah. So I work on a lot of different projects. Some of them at IBM, some of them outside of IBM. This, for example, is something that I'm doing outside of IBM as part of my YouTube channel. Hope that answers your question. Anything else? All right. Looks like we don't have any other questions about the compiler itself. But what we did do today is that we've shown you the basic logic of the pathfinding and how that's going to work within the actual part of the program that actually generates the images. Now, what we're going to do offline before our next live stream, which is going to be on a different topic, we're not going to be doing the Piet compiler once again. What we're going to do is we're going to actually fix this little error or these set of errors to make it so that this code compiles and runs the same logic. If need be, and if we change anything major, we'll create like a follow-up video or recorded video around the changes that we made made and how exactly the new Piet compiler actually works and show you a demo. Although in our next live stream, we're going to be covering something different. I'm sure it's going to be exciting, and we will be sharing that with you very soon. So do tune in next week for that. We'll be posting that on social media soon. Apart from that, once again, we will be fixing this code, releasing a follow-up recorded video around the Piet compiler soon.
So yeah, there's two questions. First one is, I'm in grade 8. How can I learn programming? I think that's probably more better for me since that's when I started program more than Tammy. He was a little kid when he started at the age of 5.
5, yeah.
I would just say just pick the way I did it. I just pick a game and just find a private server or even try to bot it and just learn Java that way and learn the fundamental over just memorizing the code. That's why like you can pick up any language afterwards if you know what a for loop is. Well, not for loop, a loop, if statements, and functions.
So the problem,
Classes are only in some languages. In Golang, classes doesn't really exist. But again, it's up to you if you really want to go into that depth. But as long as you understand the basic, that should be fine. The second one is, do you really think a MacBook Pro is enough for machine learning? Now, I can answer it quickly and then Tammy can correct me. It is enough for simple machine learning, but if you want to get into like neural network, it's not, since you need the GPU power to really help you out.
Agreed.
Other than that, if you want to do like simple NLP or even vector mapping and just do something very simple. So machine learning about 10 years ago is so possible on a Mac, but if you want to do anything that's modern, you need to go on the GPU.
Agreed.
And what you can do is go on Colab and they'll give you a free GPU.
Or cognitiveclass.ai. They
There
give
we
you
go.
free GPUs.
There's actually 3 websites that give you free GPUs.
So cognitiveclass.ai gives you the free GPUs and free courses to go along with them to actually learn how to do machine learning. Although on your Mac, they do come with AMD GPUs, and some libraries, very few of them, can leverage them. So all the Apple machine learning libraries, like Turing Crate and CrateML, do leverage the AMD GPUs for training. So you could do like basic modern deep learning, but nothing complex. If you're using TensorFlow or PyTorch, not going to run on your Mac unless you get an external GPU. And so yeah, but apart from that, no. Anything modern in terms of deep learning, I would not recommend running that on a Mac directly.
So someone asked, how do you learn coding, Tammy?
I mean, one of the and I feel so. Before I answer that question, I actually want to tie back into a previous question from Michael, which was, "How do you know so many programming languages?" And the question to answer that was, Go, for example, I've barely programmed in before, and we've still written, together, Omer and I, even though Omer's like a Go professional, like over 400 lines of Go code, and we're implementing a compiler in Go. And the reason for that is because even though I don't understand the Go language syntax, I still understand the basic building blocks that go behind a programming language, right? So, like for example, what Omer mentioned around loops and conditions and functions and structures and these sorts of things. And when you understand those basic structures, being able to program in any language is easy because then all what you're doing is you're taking a problem, mapping it to those fundamentals, and then solving the problem with that language. So really, the way that I'd like to learn programming, the way that I would recommend folks to learn programming, is by focusing on that problem solving and focusing on learning those fundamentals rather than learning, the individual syntax of a language. So what Omer mentioned around, not just memorizing Java syntax, but rather even like, for example, finding a game server and implementing bots on it or whatever, that's a great way of doing it, because that way you have a problem, you have an incentive, something that you want to do, and you're working towards solving that problem. So that is a great way to get into programming.
The funny thing is when you remove some of the fundamental that you're so used to and you have to get used to a whole new concept. That was kind of fun when I was going into doing functional programming.
Yeah.
You don't really have loops anymore because everything, or even data structure that's saved, you have to constantly recreate the data structure. It was a bit annoying, but it really get your mind off the fact that the way that you program might be different and in what language you're doing, and it takes time to get the understanding of it. But eventually, when you do, it becomes almost second nature. And when you go program another language, you'll still keep those new concepts that you learn for that language.
Mm-hmm.
Like, and a
Yeah.
good example is Tammy learned how to use for loops with labels, which is really useful in certain examples. Like,
Mhm. Just really quickly, there's another question that caught my eye here before we end today's live stream. Again, if you have any questions, feel free to send them over. But this question is: there are other laptops with NVIDIA GPUs which are cheaper than a MacBook Pro, so why do you always stick with Apple products? And I will say that for machine learning, deep learning in specific, sure, you don't necessarily need an Apple computer. You can always buy an NVIDIA GPU laptop and install Linux on it. Windows for development is a terrible experience. I wouldn't recommend it at all for any kind of development, really. But if you're using Linux on an NVIDIA GPU laptop for deep learning, totally fine. I use that myself. I've got a separate, like, laptop for deep learning itself. But when you're doing other kinds of development, being able to have a Mac environment is great because then you don't need to deal with the low-level issues like you would on Linux. It's still a good experience, but at the same time, you don't need to deal with an operating system that wasn't meant for modern development like Windows. And so you get the best of both worlds in a way, since it's based off of the same common Unix architecture. Um, so that
yeah,
answers Rutchit's question. And with that, I believe we will be ending today's live stream. I hope everybody enjoyed. Thank you for joining in. Thank you very much, Omer, for joining and providing your Go expertise to implement this Piet compiler. And we will join again next week on Wednesday, again at 10 a.m. Eastern Time. And you will be hearing more about next week's exciting topic very soon. All right. Thank you very much, everyone. Goodbye.
bye guys.